No, it's not too terrible. All right, two scenarios. Scenario number one. I don't know why this keeps popping up every single time I start writing. Scenario number one is one radical. And so I'm going to walk you through some steps on what we do to solve this, and you're probably going to know right off the bat what you do. So maybe I have something like 10 plus the square root of a plus 7 equals 11. $15, payday. Huh? Yes. Not yet. What we're going to do, if it's just one radical, see what it keeps doing? We're going to isolate the radical. Now, be careful because radicals come in all shapes, forms, and sizes, and we've learned that so far. We could have something like x to the 1/3. That is still a radical, yes? What's the radical? The third root, the cubed root of x. That's exactly right. So remember things like that exponents can still be radicals. We can have a lot of stuff under the radical or not a lot of stuff under the radical. But what I'm going to do first is get the radical by itself. How do I do that here in this one? Sure. Subtract 10. If I move the 10 over, that leaves me with the square root of a plus 7 equals what? 1. Once you have the radical isolated, bless you, I'm going to eliminate the radical. How in the world do I eliminate a radical? What gets rid of this? Give me another way. I think you're saying it wrong, but you're thinking right. Square it. Yeah, square root and square are opposite, right? Those cancel each other out. Cubed root and cubed cancel each other out. Whatever that root is, that exponent will cancel it out. So if I am square root of a plus 7 and the radical is all by itself on that side, I can raise it to the second power and then this is gone. Does that make sense? No. Who said no? Okay. Once you get the radical by itself, you get rid of that radical. And to get rid of the radical, you raise it to the power that's whatever that root is. So if I had the fifth root of x equals 3, then I'd raise both sides to the fifth power to get rid of it. Yeah. And it cancels out. That's exactly right. 1 squared is 1. That's right. That's why that one's a little confusing. And then we just solve like normal. I started with an easy one. Subtract 7. What does a equal? -6.
That was so easy.
So easy. Now, here's the little bit harder part because we're dealing with square roots. And what happens when you take the square root of a number? Like the square root of, say, 25. Or -5. So what I have to do is I have to take these numbers that I get anytime I solve a radical and plug them back in to make sure they work. Because I can't end up with a negative under the radical. So in other words, if I plug back in -6 plus 7, does that equal 1? Yeah, so the last thing is to check. And the reason I check is because sometimes it doesn't work. Okay? Now, if it does not work, which will happen often, that's why we have to check. If it doesn't work, it's what we call, I can't remember if we've talked about this in here or not. Have we talked about solutions that don't work before? Okay, that's pre-Calvin. If it doesn't work when you plug it back in, this is especially true whenever you get like 2 solutions too. One of them will work and one of them won't. The one that doesn't work is called an extraneous solution. It's just a big word that means it doesn't work when you plug it back in. That's all it means. You okay? I would just probably say solve and tell any extraneous solutions. So you would just need to label it extraneous, but you'd still solve the same way. Everything else is the same. Ooh, gracious. Nope, 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 nope. It just doesn't work. You say no solution or extraneous solution. All right, y'all ready to kick it up a notch? Huh? I'm gonna do a couple with one, and then I'll move to two. I'm gonna give you just a second to work through that and see what happens. Mark Sitko. Got fraction? Just plug it in and see if it works. So, yeah. I'm going to go ahead and start running through this. If you're still working, don't look yet. Add 9 to both sides. Yes. That's okay.
Oh, okay. See, that's what I did.
16. Okay, so yours, whenever you do it, you're going to have to put parentheses in it. Because it's what stays in the parentheses. So that all of it stays under the parentheses.
Yeah, I just didn't.
That doesn't work? So yeah, you just plug it back in. So let's see what happens when we plug it in. The fourth root of 8 times 1/2 plus 12 minus 9. Does that equal negative 11? Fourth root of 4 plus 12 minus 9. Does that work? No. So this is extraneous.
Yeah, what? Hold on.
Okay.
This is making me miss what it's
So you raised the negative. You raised the negative 2 to the 4th power?
You raise what?
You raised both sides?
Yes.
Oh. And
Yes.
You want to have
No. No, you can just look at that at that point and tell it doesn't work.
Oh, because we did it with a 1, so like the first one we didn't raise.
But as I'm looking, you think it's easy? As I'm looking, so if I'm grading yours, I'm looking for this answer, but then I'm looking for you to just tell me this. That's all. Okay? So it's not like you have to go back and find. What do you mean?
9.
And when we do this, we just take the primary root. We don't do the plus or minus on it. We just take the primary root of it. This is -7, right? Yeah, we got k as 1/2 when we solved it, but then when we found out that it was extraneous when we plugged it back in. Yeah. Yeah. That's okay. Y'all don't overthink it.
That's not bad.
Well, you do. You'd need to. I mean, you could probably do a lot of this on your calculator, and I'm okay with that. With you just saying at some point, just showing me that you plugged it in. Like if you just do this and you do this and tell me it's extraneous, I'm okay with that.
Wait, so could we just do K equals 1/2 extraneous?
Well, but plug it in and check it. But yeah, you don't have to. Like that's double work. Yeah, if you plug it in on a calculator, that's fine. No, just the positive. Just the positive. Yeah, just the positive. All right. Let's do one more with one radical that looks a little different. I'm sorry. Yeah. When we plug back in, we only take the primary root. We don't do the plus or minus on it. So always only take the positive on that one. That was a good question, though. All right, Mark, set, go. Cranking up the heat. Cranking up the heat.
Whoa, 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 whoa. What's going on? We divide? Wait, what do we do?
I don't know. You tell me. I don't know. Oh, my goodness, Harris. I don't know. What are we going to do? That sounds like a good plan. Oh, my goodness. What are we going to do with all these A's? Okay, so now everybody's saying they're stuck, but follow your steps. Isolate the radical. Is it isolated? Get rid of the radical. How do you get rid of the radical? You square it. Okay? So now I end up with 12 minus A equals, I can't do anything, are you sure? Okay, I hear move the A. Come on, guys, I know y'all can do this.
Oh, I did not do that.
I heard move the 12. Why move the 12? Because it is a quadratic. And back from Unit 1, I remember that if I have a quadratic, I make it equal 0, and then I factor and solve or use quadratic formulas to find the solutions. I told y'all Unit 1 never goes away. Never, never, never.
So you want us to
Here's this quadratic formula.
Say again? You can, but I would just factor this. What multiplies to -12 but adds to 1? +4. All right, listen, y'all. Whenever everybody talks, I know y'all are excited. But yeah, this is exciting. I can shortcut this one because there's a leading coefficient of 1. I don't have to go through all the slashing, although you still can if you want to. But when the leading coefficient's 1, these numbers are just what's going in my parentheses here. Slash it. Just go ahead and slash it. Just slash it. Now, I get two solutions here. 1 and 2, yes? Now I have to check them. So I have to go back to my original equation. Let me show you a trick you may not be aware of on your calculator. Y'all take out your calculator for just a second. I feel like I've shown y'all in here before, but maybe not. Well, it's easy. The other one's easier. It's just if you end up with 2 radicals. Are we almost out of time? When do we get out?
Dude, we only have like 10 minutes left.
Dude, stop! Let me show you how to use your calculator to help you on this. Ew. I feel like I've shown y'all this before, but maybe not. All right, what was my first solution I got? -4. If I type -4, not subtract 4, but -4, you see this button? I'm taking a shot. This button right here, this is STO. This button that says STO right here. All right, STO right here at the bottom, right beside the 1. Hit that button. Clearly, I haven't done this before. And then hit the button for X. It's right beside the alpha button. Hit enter. And what this does is this tells my calculator every time I hit X, read it as -1. So if I said 2X, it should give me -8, right? Now type the equation in, the original equation. What was that original equation? Square root.
It's above the x squared.
Hit enter, and what was the right side? 8a. Everything that's under the parenthesis, under the radical needs to be in parentheses, yes. So are those two the same thing? You don't understand. Okay.
I wasn't allowed to use a calculator now.
I'm checking -4 first, okay? What I'm gonna do, I'm gonna store X as -4, okay?
Okay.
All right. You can if you want to. It's just whenever you start messing with negative numbers, there's so much room for error, especially with radicals and squares and everything else, that if you store it there and then you just type it in exactly the way you have it here, you know you haven't made a mistake. It's just quicker for me. I just like, but you don't have to. All right, so the first solution I got was -4. I store as X. Now I type the left side of the equation, which was the square root. What was the rest of the equation? I can't remember.
12 minus a plus 7.
All that's under the radical, right? Then outside the radical, you said plus 7a. That's the equation, right? That's the left side of the equation. Hit enter. The right side of the equation is 8a, right? 8a. Make sure you got parentheses under it. Did you store X as -4?
Let me see, cuz y'all the X is -4. Okay, so the answers you got, the 20.
Since they're not the same, that's an extraneous. Yes, yes. Now, check the other one. Well, you got to check both of them. So what was the second one we had? 3x equals 3. 3 store as x. Now I'm going to type the same thing. Left side, square root, 12 minus x plus 7x. And then right side, 8x. Uh-oh. I got too many parentheses here. They're the same. So what does that tell me? Right, that's good. This is the solution. This one is extraneous. I hear all the O's.
I hear not working.
Yours is not working. Okay. Yeah, I don't think it should take long. No, it's not.
Yes, it is.
All right.
Oh, it's gonna.
Let me show you scenario 2 real quick because scenario 2 is 2 radicals. Yes. You've got to separate them. You got to get them separated. Y'all ever heard that song? Gotta get them separated. Okay. Oh my goodness. Huh? All right, so we're going to separate them if there's 2 radicals. For instance, if I have, and a lot of times they're already separated for you. Let's say the cubed root of 14 minus 10 n equals negative 2 cubed root of n. They're already separated here, yes? All right. Then step 2 is going to be raise and I'm wording this a little bit differently because this time, since there could be 2, just by raising them to a power doesn't necessarily eliminate them every time. And this one it will, but I'm gonna show you one more after this, and then I'll be done. I'll shut up, I promise. Where it doesn't work like that. Okay, so here they're separated. What power would eliminate the radicals here? Cube. So what I'm gonna do is I'm gonna come in. Be careful on these. If I raise these to the 3rd power, cancels. On the left side, it's just gone. Yes? And so I'm just left with 14 minus 10n. On the right side, it's a little bit different because there's a number in front. That number in front also gets that exponent. That's exactly right. So it's going to be negative 8. And then I've got this n right here, right? Now you can solve it. No, you can. You can. It's, yeah. Now solve it. And I'm going to say solve and check because you need to check it for extraneous. Yeah. Don't be embarrassed. Just ask. Shut up. Just ask. What? All right. How am I going to solve this? That's exactly what I would do. Get your n's together and your constants together. You could have added 8. If you added 8, then you'd have to move the 14 as well. Because you'd have 0 on one side. Doesn't really matter. And now do what? What does n equal? Check it. It's not extraneous, it works. Yeah, yeah.
How do you like the X thing? This time you put
How do you plug in the second one? What do you mean the second one?
like because I need to do it but then
Hit, so you can do -2 and then do a parenthesis. Yeah. Yeah, how many is it, like 20?
Yes, it's way too
Let me show you one scenario. Yeah, do like -2 and then do this and then do 3. Solve that one for X. If you can get this one, I'm going to stop. Tina's a little bit needy over there. She needs a little more space. What do I do? They're already separated. How? Just that? And what happens now?
Oh, I didn't see that.
Well, this just cancels. Okay. Because I can't just square one thing. I have to square. If I do it to one, if I square one whole side, then I have to square the other whole side. I can't just pick and choose pieces to square, right? I got to do the same thing to both sides. But you can't distribute an exponent like that. That's a good try. But if I'm subtracting or adding in the parentheses, I cannot just distribute that exponent through. So what do I do? Say it again louder for the people in the front. They can't hear you. FOIL. This is a FOIL problem. So, what? If I have this, I can never, ever, ever say that that's x squared plus 4. Instead, I'd have to say x plus 2, x plus 2. If you're ever adding or subtracting in the parentheses, the exponent never distributes inside. It only distributes inside when you're multiplying or dividing. Okay, so shoot. Now we just all kinds of messed up now. Well, y'all are really going to love this problem when you see what happens when you FOIL it. What's the square root of x times the square root of x? 1x. Yep, so minus square root of x. I'm done with that one. Okay, so now I have x plus 9 equals, I can add these two together because they're like radicals, right? What in the world am I going to do now? Do it again. Isolate the radical. Now I'm in scenario number 1 again. Oh my gosh, right? So I feel like I'm going around my elbow to get to my thumb, but at the end of the day, I've eliminated one of the radicals. Now I got to get back to the other radical. One of them did. So now I'm down to 1. So now I'm going to isolate this radical. Well, what's keeping it from being by itself? Well, let's see. I'm going to move the 1. I'm going to move the x. Right? So this cancels. I end up with 8 equals negative 2 root x. Now what? Divide by negative 2. All right, so look. I'm isolating this. So I move the 1. I move the 1, and I move the x. So I get negative 4 equals the square root of x. Well, what does x equal? I tell you what, for the sake of time, since I'm having to do the whole sheet, you don't have to check your extraneous. You can just solve it through. Yeah. I don't usually make you check extraneous, but if you want to, go ahead.